This is Computer Architecture CS147 Lecture 13. From next lecture, lecture 14 onwards, at least 4 or 5 lectures, we will be focusing on how to improve computer performance, computing system performance, starting from this base computing system, what an equivalent we have developed in our project, and during the lecture 11, that is the base computing system that we had. And then based on that, we'll do more theoretical studies about how can we how can we improve performance of any computing system. But before going into that, we would like to discuss or know about what do we mean by computer performance. We need to be very clear about these specific definition of what we exactly mean by the performance and how we measure the performance at all. Like, this is a quantitative analysis of computing system performance, so we need to establish some definition and standard process to measure performance so that we can compare with respect to one revision of computing system to another revision of computing system with their performance, how good or bad they are, right? And we'll also talk about general idea of improving performance of any system, not only computing system or hardware system, but any system, what would be the general approach to improve performance of any system. So let's look at first performance measurement. What do we mean by that? Now, two types of performance metrics are measured for a computing system, including the processors, as like there can be a couple of other type of computing system as well, but in general, any computing system, two metrics which are kind of very similar to each other, but they have a fundamental difference, though they sound very similar. One is the response time. So what do we mean by response time? This is a time between start and completion of a task. In computing system, we call a program, right? You start a program, you wait for some time, it ends, and this is also known as your execution time. Okay, so that is the response time of a computing system. You start your program, or you send request a computing system, okay, start my program, and you wait, and then it finish the job. That time elapsed between start and stop, that's your execution time or response time. Whereas throughput is the total amount of work done within a given time. So you can think of that a throughput is more from computing system perspective. If you think yourself a computing system, then from that angle, what we are looking for here, total amount of work done in a given time. Just an analogy, right? So let's say you have been given with 10 mathematical problem, okay, 10 mathematical problem to solve, and one person solve it like in 10 hours, another person solve it in 5 hours. Okay, so within an hour, throughput of the first person is 1 versus the next person who completed the job in 5 hours, the 10 problem in 5 hours, that person's throughput is 2 per hour. So that's the throughput, okay? Whereas response time is more like from user perspective, like you are giving a problem to the computer and how long it take to complete that problem. The same math problem analogy, if you think, okay, how much you are taking per problem, that's your response time per problem, right? That's it. So in the first person who completed that whole 10 mathematical problem in 10 hours, that means on average response time per problem of that person is 1 hour, versus the person who completed that 10 problem, mathematical problem in 5 hours, that person, from that person performance point of view, per problem that person took half an hour, right? That's the response time per problem for that person who completed the 10 problem in 5 hours. So that's the basic difference. One, response time is measured with respect to the client. Okay, like if you are thinking like client server model, that kind of analogy if you want to take. So response time is with respect to the client, from the viewpoint of the client. Like client is giving a problem and the server, how much time it takes. Whereas throughput is from the server perspective, that given amount of time, how much work I am doing. That's the throughput. So if we take these two scenarios, let's analyze what affect which type of performance. Number one scenario is replace the processor in a computer with a faster revision. Okay, so you had a processor which was running probably in 1 gigahertz clock speed, you replace it with a 2 gigahertz clock speed. So what will it affect? And secondly, and second scenario is that the processor remains same, it's still running on the 1 gigahertz, but in the computing system we are adding an additional processor, or let's say more than 1, 2, 3, 4, 5, doesn't matter, but for our discussion, but is that we are adding multiple processor which each of them has the same speed, like in 1 gigahertz, like the older system, but now I have more processor in my hand. Now which one will affect response time and which one will affect the throughput in the overall computing system? So the first scenario, where we replaced the computing system's processor with a high-speed processor, of course, normal thinking would be, like natural thinking would be, it will improve the response time, right? Because it's running faster, so given a problem, it will just solve it faster, right? Twice. It's not twice in a real system, but if you increase like 2x in the clock speed, overall experience probably will end up in 1.2, 1.5, depending on what type of improvement we are making. We'll see that type of problem later as well. So where we'll prove that if we increase the processor performance by 2x, like 1 gigahertz processor to 2 gigahertz processor, we cannot expect that all the program will run twice faster. Okay. But anyway, the general feeling is that it will improve the response time. Okay. Whereas adding an additional processor to a system, one or more processor to a system, what it will do now, you can do multiple job in parallels, right? Because one processor can take up one job, another processor can take up one job, another processor can take another job. So that means from the computing system perspective, your throughput is increasing, right? Your throughput is increasing. So within a given time, the new computing system having multiple processor is increased with the throughput, but since each of the processor is running like an old machine with a 1 gigahertz, and then each program execution time will remain same, right? Of course, in real life scenario, it don't remain same. That's a different story, but we can give or take that they're almost same per program. So execution time is not going to improve. That is the general sense, right? But throughput will, because the new system is now can cater or finish more job in a shorter amount of time. In a given amount of time, not shorter, given amount of time. But if we think both the scenario in little deeper detail, then let's see what will happen. First scenario, you are replacing the processor with a faster processor. Definitely it will decrease your runtime for a given program, right? That means response time will improve. That means in a turn, if you think from a computing system perspective, that computing system can finish within a given time period, like 1 hour, 2 hour, 3 hour, whatever our measurement point is, can finish more job than its predecessor, right? Because its response time is reduced now. So in a constant amount of time, it can finish more job. So your throughput is improved, right? First scenario. Second scenario, if you think this way, like we can think second scenario two different ways. First way, you think okay, I have like 10 processors added into the computing system, and there has been request for like 100 different jobs, like they're in a queue. In previous scenario, job 1 will be done first, then job 2, then job 3, then job 4, then job 5, and till like that in 100, right? So that means from individual jobs point of view, when you request the computing system, you are not guaranteed that your program will be executing immediately, right? You will be placed in a queue. That let's say you are in a 50th position of the queue. So you will have a wait time before even your job is start. So from your perspective, you requested this computing system to execute a job, and you are just started your stopwatch to collect how much it take. So depending on the queue length, how much job is requested before you, your execution time will vary, right? So of course with the one processor there, the queue will move slower than if the computing system has 10 processor. Because a computing system with a 10 processor, 10 jobs can be starting executed in parallel with that. That means your queue will move faster in that case compared to a computing system have single processor where queue is moving slower. So in that way, in that thought process, you can immediately see that your execution time or response time, not I won't say execution time really in that case, but response time from the system is much more for a computing system having one processor versus a computing system has 10 processor. So the second scenario, that you are adding more processor to the computing system, it will increase the throughput, through which it will also increase the response time from the user perspective. Okay, so both scenario will improve your response time. The second scenario we can think of a little bit different way as well. Let's say there is no queue or something like that. You can just start your program right away. Now, since you know your computing system and 10 processor, then you can implement your program in a multi-threading, multi-processing approach, right? It's all about parallel programming aspect. So you can re-implement or you can change your program to take advantage the fact that you have 10 processor now. Then you can divide your problem into 10 different subtasks, and those subtasks, if they can be done in parallel, you just schedule it for 10 different processor. So that way also you can think your response time will go down, right? Response time will improve. So two different approach of improving performance affects both response time and your throughput time. Now question is like, how do we measure a performance of a system? It's very simple definition. It's a reciprocal of execution time. So you can measure the execution time of your program. Your performance is just 1 by E. Now, to compare performance of two systems X and Y, what we all do, the ratio of performance of system X with the performance Y, by the definition of performance in terms of execution time, it becomes ratio of execution time in Y with the execution time in X. So Px by Py equal to Ey by Ex. So that comes straight from the definition.